Welcome to section 9.5. This is distance in coordinate geometry. And I'm going to start off with an example from the textbook. You don't have to have this open, but I'm just going to take a look at it. So we've got this grid, and we've got 1st, 2nd, 3rd, 4th, all the way up through 8th Street, 1st Ave through 8th Ave. We've got two friends on two different corners. This is Scott, he's over here, and this is Vicky, she's over here. Vicky is standing on the corner of 7th Street and 8th Avenue, and her brother Scott is on the corner of 2nd Street and 3rd Avenue. To find the shortest sidewalk route to Scott, Vicky can simply count blocks. So Vicky can go like this, boom, 2, 3, 4, 5 blocks this way, and 1, 2, 3, 4, 5 blocks this way. But if Vicky wants to know her diagonal distance to Scott, as if she were like flying over like as the crow flies this way, then she would need the Pythagorean theorem to measure across blocks. This comes up in a lot of different ways. Let's take a look. So we can see this vertical distance is 5, and this horizontal distance is 5 also. So if she were to walk blocks, it would be 10 blocks. But if she were to fly, going directly, then it would be about 7.1 blocks. We know that from yesterday. This is a 45, 45, 90 triangle. It happens to be one. We're not actually going to see a whole lot of 45, 45, 90 triangles or 30, 60, 90 triangles today. But I know that this would be 5 square root of 2. Or you could use the Pythagorean theorem to get 7.1. Either way works. So the question is, how do we find, this is really illustrating the point of how do we find distance between points that are on a graph. And you can see what we're going to do is we're going to take all of these distances and turn them into right triangles. This is the x-axis, this is the y-axis, and if you want to find the distance between these 2 points, then you can count out the spaces. Oh, by the way, any of you who have ever had difficulty counting, like, I know it sounds strange and maybe even a little childish, but it's actually not that simple to always count these lines correctly. Sometimes people count too many lines or too few lines. If that's ever been you, and you don't have a really great system for counting the space between this and this, I would suggest counting spaces. Don't focus on the lines, focus on the spaces. 1 space, 2 space, 3 space, 4 spaces. You'll get it right every time. 1 space, 2 spaces is the horizontal distance here. So use the Pythagorean theorem. 2 squared plus 4 squared equals d squared. And we'll use a decimal answer for today because it's a kind of a practical thing. We want to know what the distance is. It's 4.5. And you can see it's longer than either 4 or 2. Let's count the spaces. 1 space, 2 space, 3 space, 4 space, 5, 6 spaces, 1 space, 2 space. And so you can see this is a vertical distance of 2, horizontal distance of 6. And using the Pythagorean theorem like this, then we can get the hypotenuse, the length of the hypotenuse is going to be the distance, and that's 6.3. Again, finding the distance between 2 points, any 2 points on a graph, is boiled down to basically finding, drawing a right triangle like this. 2, 8d, we get 2 squared plus 8 squared is equal to d squared. I want you to find out what d is, and pause the video, and then when you're ready to move on, actually, I want you to find out what this d is, and then find out what this d is also. What is the distance between these 2 points? Both of them are in the back of the packet. Now, one thing we could have done, if we wanted to, since these are numbers, 8th Ave to 3rd Ave, we could, instead of counting spaces, you could have just subtracted 8 minus 3 is 5. 7th Street to 2nd Street, you can subtract 7 minus 2 is 5. So that's actually really helpful to do if counting spaces is not convenient. Look at these huge numbers, 70. I'm not going to count 70 spaces or 34. What? That's ridiculous. Way better, way simpler to subtract. This is the y value here, y2, and this is y1 right here. And so the vertical distance is going to be the 2 of them subtracted. The horizontal distance is going to be these 2 subtracted. 70 minus 34 is 36. 42 minus 15 is 27. And in fact, this is going to be a convention, these color conventions I'm going to use. Anytime we're talking about a horizontal distance for the rest of the video, it's going to be in blue, and vertical is going to be in orange or this peach color. So we can take this distance of 27 and 36 and use them in the Pythagorean theorem. And when I write AB, that's the distance between point A and point B. AB is right here. AB is the length of a segment in geometry. So the length of that segment is going to be represented here in the Pythagorean theorem. AB is equal to the square root of all this squared and added up. It's 20, 25. You take the square root, it happens to be 45. Great. Now, this idea of subtraction and using the Pythagorean theorem, instead of drawing out the picture every time, it's actually going to be way simpler to just get a formula or one equation. So here are two versions of that equation. You can see here we've got the horizontal distance squared. That would be these two subtracted. You see, we use subtraction here, so this subtraction finds the horizontal distance. This subtraction finds the vertical distance, and then they're related with the Pythagorean theorem. Or if you want to take the square root of both sides and just have something you can plug directly into your calculator, then this is it. The distance is going to be equal to the square root of all of this, and when you type it into your calculator, make sure you use parentheses. Square root of all of this, and then here, x2 minus x1 squared plus y2 minus y1 squared. This is super tricky, and it's really complicated looking, but if we can use it, then this gives us something we can very easily express one step in a calculator. Like this. Turn it on, and you get to this opening page. I'm going to press the letter A for a calculate scratchpad. And there it is, A. And now I'm going to take the square root. That would be control of this button, square root symbol. And notice everything I'm going to be typing is going to be inside of this square root. So we're going to have open parentheses, and then I'm just going to make up some numbers. It's going to be, say, 9 minus 2. I'm going to go right arrow squared. So you can see very clearly here it's 9 minus 2 inside parentheses squared. And now the plus, I'm still inside the square root. It keeps on getting longer and longer to contain everything that's here. I'm going to make up some more numbers. Parentheses 5 minus negative 5. Close the parentheses, squared. Enter. And that's the distance between these 2 points. Now, this formula over here can also be used to get to be able to graph a circle. Now, maybe you've graphed lines before in Algebra 1, but here's how you graph a circle. It's basically coming out of the distance formula. A circle is defined as all of the points that are a certain distance away from a single point. So if you know the center point and you know the radius, then you should be able to find out all the other points. And that's how the graph is expressed. The center is, we'll call it, in general, we call it like h comma k. That's where the center is. The x value of the center is what we call h, and then the k value of the center is what we call k. Just kind of like the slope is usually m, and the y-intercept is b. The number that you solve for is x, whatever. So h and k, that's what we normally have. So if you want to know where the center is, then you can put it in here, h and k. You notice this equation looks very similar to this one right here. So you're trying to find the distance between hk and xy, and that distance is going to be a set radius r. If you want to make up some numbers like 1, 2, and 4, or 1, 2, and 2, then you can plot them, and I'll show you how. Okay, this is how you graph a circle. So I'm going to do a scratch pad, and I don't want to calculate anything, I want to do a graph. So I'm going to press the letter B, and there's a graph, and you can see it comes up with f1 of x. This is kind of like a function. Now if you wanted to do like a graph of y equals 3x plus 2, that'd be a straight line. That's what it looks like. But that's not what I want. I want a circle. I'm going to go to menu, press the menu button, 3 graph entry edit. So what I really want is a relation. Relation allows me to type in equations that are like circles. So I'm going to type in, again, I just want to do it one more time. Menu button, 3 relation. Boom, relation. And now it's telling me this is where I type in my first relation number 1. And I can use x and y as variables. So x, I'm just going to type in make up some random numbers. X minus 1, and then we're going to go squared. There's the squared button. And then plus parentheses y minus 2, close parentheses, squared. And then I'm going to type in the equal sign, which is right here, equal sign. And then we'll let the radius equal 4. Radius is 2, so 2 squared is 4. And then hit enter. And there it is. Here's our relation, and it's even labeled. And if you want to use the trackpad, you can even move it if you wanted to. You can move it over here, and the equation adjusts. You could even stretch it out a bit if you can use the trackpad well. Changing the radius is over there. Changing the x and y values is over here. The h and k value is right here. So that's the equation of a circle. All right, now let's find some distances. Here's the big equation that we have for distance is this. I'm just going to copy it again up here at the top so we can use it. So what we're going to do is we're going to take these 4 numbers from the 2 different points and we're going to plug them in the right place right here. So my strong recommendation would be to write x1, y1, x2, y2, because this is the first point, point number 1, and this is point number 2. And this is its x value, and this is its y value, x value, y value. And honestly, the hardest part about this is keeping track of all the numbers and where they go. So what you need is a really great system, and I think the easiest way to do it is just write x1, y1, x2, y2, so that you know when you compare it to the formula here, you know that, okay, I got to write x2 first, and it goes here, 13, 13. Then I write x1 is 10, 10. Then I write 16 next because that's y2, and I write y1 next because that's 20. And now you can type all that into your calculator and hit the answer and you get 5. Same thing again here for number 2. Here you can, looking at the formula, you know you need, this is x1, y1, x2, y2. Make sure you write it up top, helps you stay organized. As you and I know both know very well, staying organized is half of getting answers right in math. It's not innate smartness or whatever. Students who stay organized are more likely to get it right. So stay organized. Here's your organizational scheme: x1, y1, x2, y2. Write it up top. 42 minus 15. I know that's 42 because it's going to be, this is 42 and this is 15. So this is the horizontal distance squared. And then this is the vertical distance, the distance between 73 and 37 here. What I'd like you to do is type that in your calculator, hit enter, write the answer here, and check it in the back of the packet. Again, here we've got x1, y1, x2, y2. This is what it looks like. It's a little more tricky because there's negatives here, and so I've separated out with some parentheses. I don't think the calculator actually requires these parentheses, but I like them because it helps me stay organized and I can see it better that these are negative numbers. Anyway, there it is. Hit enter, and check your answer in the back. Find the perimeter of triangle ABC with vertices A, B, and C. I think it helps to visualize things a little, to write them all down. So I'm going to say A is this red point, B is this blue point, and C is this green point. Now, in order to find the perimeter, what you've got to do is you've got to find all 3 lengths. And I'll find the first one for you, with you. This is A. A is at 2, 4, and B is at 8, 12. Here it is. And so I've written x1, y1, x2, y2. That's going to change down here. Every time you find a different segment, what you call point 1 and point 2 is going to be different. But for right now, this is point 1 and this is point 2. So x2 is 8 minus x1, which is 2. 8 minus 2 is squared, and then 12 minus 4 is squared. When you type all of that in the calculator and you hit enter, you get 10. You actually, if you wanted to, this 8 minus 2, you could do it by hand. 8 minus 2 is 6, squared is 36. 12 minus 4 is 8, squared is 64. You could write down multi-step, 36 plus 64 is 100. Then you take the square root of 100, you get 10. But that's not really going to be my focus here and now. We just make sure we know how to plug them into the formula and get the right answer. What I'd like you to do is I'd like you to find the distance between A and C. It'd be this distance right here. And then you can do that by finding the distance between the 2 points. Consider this point 1, A, and this now is going to be point 2. And so use the distance formula to find the answer. Repeat that again for BC, and then add all these up. 1, 2, 3, to find out what the sum total is, and check it in the back of the packet. pause the video, and then I'm going to move on. Now, here, the equation of a circle I've copied down here. Horizontally, the distance, the horizontal location of the center of the circle is h, and the center of the circle has a y value of k, and then the radius of the whole circle is going to be this. So if I know what the center is, this is going to be the value of h, and this is going to be the value of k, and they tell me that this is r. I'm going to plug these three numbers into the equation, and if I wanted to graph this, this is what it would look like. This is the equation of the circle. You can type that into as a relation onto the graph on your calculator, and a circle of radius 4 with a center at 3, 1 should show up. Can you figure out what should go here? Figure out where these numbers should go, in particular right here, and then check your answer in the back of the book. Now we're going to go the other way. We're given the equation, and can we figure out what the center is? Well, I think this is the center. H is going to be 2. Okay, this is tricky because we have a y plus 5, and the formula expects subtraction here. It's always x minus, y minus. And if you're given plus, then what you really need to do is take the opposite. I see a positive 5, but this is y minus negative 5. If you wanted if you want to know why this is true, then you can go backwards and say, well, 2 minuses make a plus, so this is y plus 5. It's more convenient to read this form so that we know that k is equal to negative 5. 2, negative 5, 6 is the values of h, k, and r. So you tell me what is the center, and you can check it in the back of the packet. Number 10, I'd like you to write the equation, check it in the back of the packet, take photos of all your work for this section, upload it to Haiku Power School, and consider it a done day.